हरि करना।
Okay, so now let's build a Poisson distribution from scratch, a step-by-step guide. So to build a Poisson distribution, we first need to understand its properties and parameters. The Poisson distribution is a discrete probability distribution that represents the number of events occurring in a fixed interval of time or space. Given that these events occur at a constant rate and independently of each other. So the Poisson distribution has only one parameter, which is the mean and lambda, or rate of occurrence of the events. So to build a Poisson distribution, we have to follow certain steps. So out of them, the first one is determine the mean or average value of the Poisson distribution, which is denoted as a lambda. Then choose a range of possible values for the random variable, usually from 0 to some maximum value. Then for each possible value of the random variable, calculate the probability of that value occurring using the Poisson's probability mass function, which is given by P of capital X is equals to small x is equal to, yep, this equal to has come here, and then lambda power x multiplied by e power minus lambda divided by x factorial. So here P of x is equals to P of capital X is equals to small x. So the probability of exactly x occurrences in a given interval, lambda, so mean number of occurrences during interval. So in that particular interval, mean number of occurrences, and small x is number of occurrences desired. P, this is probability, and small x is number of occurrences desired. Lambda is the mean number of occurrences during interval, and E is the base of the natural algorithm. That's it. So that's how we calculate the possible value of the random variable using the mass function, probability mass function. So then we calculate the cumulative probabilities up to each possible value of the random variable, which gives the cumulative distribution function. So one is mass function and other one is cumulative distribution function, CDF. So then once that is done, we can plot the probability mass function, that's PMF, and also the cumulative distribution function CDF to visualize the Poisson distribution. So now let's take one example and illustrate this one. Okay, so this is Poisson distribution. So suppose we are interested in modeling the number of customers. I am writing down. We are interested in modeling the number of customers who enter a store during a certain, we are worried only about certain time period based on historical data. So from the data we determine that the average number of customers who enter the store during this time period is 5. So now as step 1 we have the value, that's the mean value of the Poisson distribution. So mean value of the Poisson distribution which is lambda is equals to 5. Next, step 2, we choose a range of possible values from the number of customers from 0 to 15. Zero to 15. So then step 3, for each possible value of the number of customers, we calculate the probability of that value occurring using the Poisson probability mass function. So Poisson probability mass function. So that is nothing but P of x is equals to small x and lambda power x multiplied by e power minus lambda divided by x factorial. So once that is done, then we will move on to the next step. Once you have calculated the respective probability, so now we calculate the cumulative probability. We will calculate the cumulative probabilities up to each possible value of the number of customers, which gives the CDF, which is cumulative distribution function. So for that we'll take that value is 3. So once that is done, so next it's to plot, nothing else. Pretty straightforward. Step 5 is to plot the results. Okay. So now let's take one example. So I have written the code. So I'll just copy the code from here and paste it here. So step 1, okay, initially we have to import PLT, NumPy, then Poisson from stats module. Then set the mean value of the Poisson distribution, that's a lamb is equals to 5. Once that is done, you have to choose a range of possible values for the number of customers. So range of possible values I'm choosing from 0 to 16. Okay. So once that is done, so I have to calculate the PMF and probability mass function from the Poisson. You can take the method, PMF method, and similarly for CDF, you can take CDF method and you can plot both PMF and CDF, and you can see here. So this is probability mass function that you can see. It's depends upon the number of customers. We want to see from 0 to 16. So what is the probability in that particular interval? So this particular interval, what is the probability that 2 customers will enter? What is the probability that 6 customers will enter? What is the probability that 12 customers will enter? So that's what it's particularly giving to the respective customer. But when it comes to the cumulative, and every probability will be added. It starts from here, then both were added, and keep on adding. But when it comes to the 16, the probability because it's a cumulative probability, it will be keep on adding and it will go up. So here actual absolute probability of the 16 customers entering into the shop is very low, but here if you see it's very high. So that's what no that's a cumulative probability function, and then this one is just probability mass function PMF, and then cumulative distribution function. These are the two. But I hope you got the point. What is Poisson distribution? Poisson distribution is nothing but plotting occurrence of any event in a particular interval of time. That's it. What's the probability? So here you got the probability, or else you could have used the frequency also. But the most important thing, it's no the number of events in that particular event, the probability of happening that number of events in that particular interval. That's what we'll get it from Poisson, and this is the example that you can see. And this is another example similar to that. So here also you can see the similar kind of result. Here the number of events x which we taken on x, and then probability of happening these events is on y-axis. So probability of happening 0 events is 0.05, and probability of happening in that particular interval, it could be anything from 9 to 15, 9 to from morning 9 o'clock till afternoon 5 o'clock, or from morning 9 o'clock till night 9 o'clock. It would be depends upon the shop, or it would be dependent on the workshop or manufacturing hub. So that's what the number of events would be on x-axis, and then the probability of occurrence of that event in that particular interval is what the Poisson distribution is going to give. But for you to calculate that probability, the most important thing is you need to take up the historical data, and then using the historical data, you have to calculate the mean on an average every day in that particular interval. On an average, how many events are happening in that particular interval. So that's what is minimum requirement. If that is there, remaining things can be calculated and plotted as a Poisson distribution, and this is what a Poisson distribution for you.